Awesome. Hello, everyone. And what the hell is up with AI, as in artificial intelligence, and medicine? How did these things cross over? It seems like it's a really big question, right? We're always worried about, are robots going to take over the world? Or are maybe humans imperfect and we could use computers? Who gets to draw those lines? Who gets to make the rules? And so I know nothing about this. I got some of your questions of like, hey, did you do this in your PhD? And like, absolutely not. Anyone who's seen me around a computer would strongly recommend against that. So instead, I've brought on one of my very, very close friends, Jeff Snell. Jeff is a data scientist, physician, hybrid thing of all of the different sciences. I told him specifically we cannot talk about space because that's also one of his favorite things. So today we're going to be talking about some of his work where he's doing radiology, AI work, trying to make doctors' jobs a little bit easier, streamline some processes, but also we're going to branch out and ask some of your questions related to anything from computer science to the ethics of computers in medicine. Just a quick reminder, if you would go ahead and do the like, subscribe, all of that stuff. If you want to share, that's awesome too. I know it's repetitive, but it also helps me to keep going and tells me that this is actually something that people want to watch. So feel free to drop your questions in the box that's going on, and we are going to pop over to Jeff. Hello, Jeff.
Hey,
How are you doing?
I'm good. How are you, Susie?
I'm so good. So you're in Berkeley, California. What are you doing there?
Yeah, so I'm a physician data scientist at a radiology AI startup here. So just break that down a little bit. So I went to medical school, and then medical school, I kind of realized that machines could outperform physicians in like very narrow fields. But it kind of seemed like, that was the worst it was ever going to be. So where I met Susie was, in PhD at UNC. We were in slightly different things, but I did most of a PhD in computational biology, so kind of like applying computational methods to medicine, and then landed me a job out here in the Bay Area, kind of trying to make doctors' jobs easier. There's a lot of hype about like automating all of radiology away, but that's still a couple years away at least. We're just kind of like doing small chunks of it and like making their lives easier and more streamlined for now, as we kind of like collect more and more data to do more and more of their jobs.
So, okay. So I want to first break down, like, what is radiology? I realized this right before the call, and I was like, it's pictures of insides.
Yeah, so it's like, chest x-rays or CT scans or MRIs or ultrasounds. It's just any way of, using technology to look inside of a human body.
Oh, okay. So I wasn't that far off. Cool, cool. And just like in one sentence, describe AI. No, not really, but like when people think of AI, what are they thinking of, and why are they wrong?
Yeah, I mean, AI, the artificial intelligence term, has kind of just like come to just mean everything basically that computers are doing that kind of mimic human intelligence. So artificial intelligence is kind of just like this big broad term of anything that a computer can do that kind of mimics things that humans do. So calculators are super intelligent. They can add and multiply and divide and all that stuff, much greater than humans, but they can't do anything else. And similarly, like some machine learning can, classify text very well or translate things very well, but usually they can't really do anything else very well. And so the artificial intelligence term is kind of like a little bit too far out there, I would say, for the place that we're at. Like, we're nowhere near Terminators. We're nowhere near things making like their own decisions. Like, you can't even, just say, hey, here's this data set, go try to find something about it. Like, you have to.
So it's not like a PhD student. You can't just be like, here's some trash, enjoy.
Right. Yeah. It takes a lot more hand holding and loving than, PhD student is ever going to get.
Well, yeah. I just want to ask all these questions because I'm just going to make it very clear that I have no idea what we're talking about. But I definitely resonate with that part of just like, I keep hearing about AI and especially the term machine learning. I feel like everyone I've talked to, machine learning is like the tech version of microbiome in biology, where people are just like, let's just stick machine learning on it. Like, we've got a problem, just like stick machine learning. Is that the same as AI?
So I guess it depends on how you categorize it, but so a lot of people when they say machine learning, they mean like statistical kind of methods, like that we've all heard of, like linear regression and support vector machines, and even like dimensionality reductions like PCA. But it kind of is. It's not really separate, kind of, because you're still using similar math, but there's kind of like this demarcation between like machine learning and like deep learning. And deep learning is like where you have these artificial neural networks that are capable of doing like more advanced things. Classifying an image as a puppy or a cat, or classifying text or doing translation with text. That kind of stuff is kind of where deep learning starts to really outperform things, and where you start to kind of get into like this AI type stuff. But usually when people say AI, they're kind of talking about multiple machine learning or deep learning things put together so that you're getting multiple inputs and you're kind of able to make a decision that can benefit the users in some way that wasn't previously possible.
That's pretty cool.
Yeah, and what's interesting is every time you kind of like you build an AI tool or whatever, and you solve some problem, it's no longer AI, like it's no longer intelligence. So, in the 80s and early 90s, people would have said that like if you can build a machine that can beat the greatest human chess player, that would be intelligent. And when IBM did it with Deep Blue in 1997, after that, it's like, oh, okay, cool. Like chess, like I can download an app right now and it will destroy anyone in chess ever. And when AlphaGo from DeepMind, beat the best human player at Go a couple years ago, it was kind of like, yeah, that is like the next thing after chess, and it's got way more possibilities, and like you can't actually just like enumerate every single possibility. So like it takes some like level of intelligence or strategy or something to do this. But after they did this, it was kind of like, oh, okay, cool. Like it beat this. It's pretty good at chess as well, but it can't really do anything else.
Yeah.
Like you can't use that neural net to classify radiology. Like you have to. It's only good at that one thing. It's like the calculator, basically. The example I gave earlier.
So there's not really like a translatability over from, okay, we made a super smart machine for this thing, and so it's got to be, this program is super smart at understanding things. Like you're just going to be creating new stuff.
Right. And so that's where people get into this thing called AGI, or artificial general intelligence. And so like humans are, we kind of consider humans to be like a general intelligence that, that grad student that you mentioned, like you can give them a task and they'll figure out how to download the data. They'll figure out how to like get the data in a nice format. They'll figure out how to train the neural net, and they'll figure out how to do, whatever post-processing needs to be done, right? Yeah. Like you can go out and like you can think about like how to solve all those problems and then like actually solve those problems. The neural net can only do one thing currently. And there's people have hypotheses for like strategies that you could kind of like take to potentially get this like generalizability across all tasks, our brain is not just like one giant neural net, really. It's kind of a bunch of different modules, right? Like you got like Broca's area for like dealing with speech. You've got a vision center, you've got like a coordination center, you've got like sensory and motor and all this stuff.
Geez, okay. There's a lot to unpack. I'm also just laughing right now because I'm like, wow, that's a lot of different topics I don't know anything about. And how do you think? I guess this is a question that I just have, but do you think it's important that you have both the MD and you're working in bioinformatics? Like, is it necessary for you to have that background?
For me, yes, but like, the company I work at, it's a startup here. It's a typical Bay Area startup, and the people I work with, like, there's an MD who's a radiologist who knows way more about radiology than I do, and he's very good at doing the radiology stuff. And then we've got like some machine learning experts. We got a guy who's got a PhD in computer vision, and a guy with a master's in natural language processing, I think. And like they know way more about the machine learning and deep learning side than I do. But like the intersection where like medicine and machine learning come together, where like I know quite a bit about medicine and quite a bit about machine learning, that like since it all happens in one brain, it helps like speed up tasks. So like
that is the most computery version of this explanation that you could say. Like, well, because it's happening in one central processor,
yeah.
that integration, we really don't need to worry about any missed data.
Yeah. Well, yeah, it misses some, but like not having to communicate, like not having to go back and forth between everyone allows, if I need to build a classifier to classify, some CT reports as, being like CTAs versus not CTAs.
Wait, what? Who's a CTA?
There's a special CT that like it's a subclass of CT. Like if I just want to go get all those out of our data set because they're not labeled, you have to build something to be able to do that. And if I only knew medicine and I had to communicate to the machine learning guys how to build this, we have to go back and forth on it a couple times, and that would take I don't know, several days to a week. Whereas like just knowing enough about each allows me to like rapidly like build the thing, test it, fix cases where it doesn't work, retrain it, that kind of thing. So like there's places for everyone, but like knowing the biology and the medicine and knowing some of the machine learning stuff is like makes you like much more like capable of solving a wider variety of tasks much quicker.
I'll buy it. All right, so yeah, questions. You mentioned image analysis, and one of the big things that's being talked about online right now is human biases in image analyses, and also like sample biases. So I've got a question from, I always pick the handles that I cannot pronounce.
What's your
Absquataloot. I get it. Okay, it says, how will the innately biased humans who create the AI impact AI's judgment, and how can that be overcome?
Yeah, I mean, that's a huge field right now. One of the issues, and I don't know, there's actually a huge debate on this going on Twitter right now in the machine learning community, about like where all the bias comes from. And there's a lot of different, and I don't want to get into that too much, but like, yeah. One of the most obvious and things that's been making the news is that the bias in the data sets. So for example, there's this huge data set called ImageNet, and I'm pretty sure it's the newest ImageNet data set. It's like 10 million images total or something. But there's been some analysis by academics lately that show like people with darker skin are more likely to be categorized as terrorists or not as scientists or like other things like this. And so like, and that comes down to the bias of the humans who are doing the initial labeling. So like, this is 10 million images that have been pulled from Google basically. And then they put them in front of like 5 to 10, we'll say, human annotators on usually Amazon Mechanical Turk. So you just give a bunch of people images and you pay them like a couple cents an image or something and classify it to say, like, what do you see in this image? And, they have multiple people look at it so that you can kind of get like a distribution of what people think it is.
Sure.
And, if 3 people say it's a scientist, then, that's probably a scientist.
Yeah.
And so this data set's kind of encoding the biases of human annotators. And so removing that bias out of the data set is very challenging. And from the medicine side, like, you want some amount of bias going in, right? Like, different groups of people have different incidence of disease, and you want to know that, whether it be based on age, race, like whether you're a male or female, like that definitely matters from the doctor's point of view, right? But like, if your data set has some innate bias to it, just because you got a bunch of radiology images that are African Americans and they came from like an urban poor area, and then but the overwhelming majority of your data set comes from like some affluent Caucasian population, then like if that's the majority of your data set is balanced inappropriately in that way. And we know that people who have more money get better healthcare in the United States. And so like, are these people like doing better because because they have more money and they have access to better healthcare. And so like if that gets encoded into our classifier in some way, which, you know, I work hard to try to avoid that kind of bias, but it still happens. And so the way we do this is we try to get an even distribution of data, like from across the United States, everywhere. And we try to avoid putting things into the inputs of our models like race or zip code or names or anything like that. So.
So I feel like, I mean, it is this really crossover thing, and kind of what we're talking about is that at this point it's not autonomous, right? This isn't like we've programmed a robot to make robots. Right. Human bias, this can possibly used as a way to perpetuate bias, and what you were saying in terms of like we do need to have some bias. Like I think that's the difference between this very intentional, you know, you don't want to do analyses on people who have a vagina. You don't want to do an analysis on them looking for prostate cancer and saying like, wow, half of the people in Iowa are really resilient to prostate cancer, and then realizing like your population is totally skewed. You need to be able to think about those data, and the bias is you're only going to be looking at men, or in that case, like you're only going to be looking at people who have a prostate. So that's okay, so this is a fun one. At Mawarid says, do you watch Netflix Black Mirror? There's so much AI medicine hybrid gone wrong. Do you enjoy these like weird conspiracy theories or predictions of how robots are going to end the world?
Yes, definitely. I've watched most of Black Mirror and Terminator is one of my more favorite of the movies. But I mean, yeah, most of them are like so ridiculously wrong. Right? Like I'm not worried about a super intelligent AI taking over the world anytime soon. Maybe in the future, but not anytime soon, because I'm actually way more worried about like our AI like doing something really stupid. Like making some error based on some bias that's in the training data that we weren't able to find or undo. Or like people using it in some like really messed up way. So like deep fakes were a big thing. Like people, you can now take, like, you take this video of me right now and you could train this. It's similar to deep fakes, but you could basically train a model to recognize your face, and then you could look into a camera, talk and say and move however you wanted, and then this deep learning model would put all of that onto my face.
Oh my gosh. That's what we're doing from now on. It's just going to be me interviewing smarter me.
Yeah, it's like it's the ultimate like puppeting basically. But you can change people's voice and you can do all this stuff. And so like that, so you could have, you could have politicians reading things that are all kinds of inappropriate and get them in trouble, or say things, potentially start wars, like all this stuff. But at the same time, like that's like the like bad use of that technology. And at the same time, you also have good use of that technology. So like in like we have this thing that can write in the style of radiologists, like specific radiologists. So if a given radiologist has more than like 10,000 reports, then our AI can learn to write in their style. And so like helping speed them up helps, like the way that we help speed them up is by writing in their style. So they don't have to like, I had this preference, I wanted to say it like this. It's the same thing as like when you autocomplete an email, like you wanted to write in like what you were wanting to say.
Yeah.
And so like, that's kind of like the good side. And so a lot of like futurists and people who care about technology will look back and say like, every kind of technology has like a positive and a negative. Like, atomic weapons are like really, really bad, but they also are like a super good like fuel source for energy. So that's where I kind of see like some of the stuff that gets made into like Hollywood like blockbusters and stuff versus like the actual reality.
And I feel like the stuff that we would have thought would be scary 10 years ago is just really helpful right now. Like when I'm writing an email and I type in th and it's like, thanks so much for responding to me. And I was like, thank you, Gmail, because my fingers are tired from just scrolling the internet all day. Thanks for giving me more time for that. But seriously, I mean, it is taking out some of the tedium that I don't think really anyone misses, which actually brings up, where'd that question go? So question Luis Carlos OR is asking, so in a while, AI will be, or like machines, computers will be used more and more as assistants to doctors. And that's kind of what we've been talking about, is that it might not necessarily be that doctors are replaced, but they become, like they get their little robot assistant, or in radiology, they don't have to do all of that technical stuff. So Luis asks, how is AI going to influence medical students? How is computer science going to be integrated to these things?
Yeah, so that's actually a really good question. A lot of this stuff so far has kind of taken over what would typically be called like medical specialists, as opposed to kind of like general practitioners. Mm-hmm. So one of the hypotheses, and so like, let me just go into that a little bit. So one of the earlier papers that got published, it was like 2017 in Nature, was using convolutional neural nets to recognize melanoma. So you can take a picture of a skin lesion, and it would tell you if it was a melanoma or not, if it was benign or malignant. And that was just an academic paper, but that's kind of been the trend. So like the
plant thing, you can take a picture of a plant now, and it tells you what kind of plant it is.
Yes, exactly. Except for like
useful
diseases and stuff. Yeah. Yeah, or hot dog, not hot dog from HBO's Silicon Valley, but yeah, it will tell you if it's a hot dog or not. But
okay, we're learning a lot of things that I don't know, including computer science, hot dog, not hot dog, and then you didn't get to see my face that I have never seen the Terminator, so that is now in the chats. So I'm sorry.
It's embarrassing. What was I going to say? Okay, so the first FDA-approved kind of medical AI tool was IDXDR. And so, like, what this thing is that, so, I don't know, like a third of the population has diabetes. And once a year, you're supposed to be screened for diabetic retinopathy. And this is just, you typically would have to go to an ophthalmologist to have, like, a look at your retina with a fundoscopic exam. But what IDXDR allows is, like, a primary care physician can do a fundoscopic exam, which everyone learns in medical school. Take a picture of the funduses, both fundus, send it up to the cloud. It runs it through their deep learning algorithm, and it sends it back. All it does, it can't do anything else. And all it's FDA approved to do is say whether you have mild diabetic retinopathy or not. If you don't, you just come back in a year for this exam again. And if you do, then you go to the ophthalmologist. So now the ophthalmologists aren't wasting their time doing all these screening exams. Right, so they're a medical specialist, and whose time is extremely expensive and valuable. And so now, the diabetic patient no longer has to go to an additional appointment, which is annoying to begin with, but expensive and time consuming and all this stuff.
Yeah.
And so that seems to be the trend currently, is like all these kind of deep learning medical startups are chipping away at specialist practice. And like they're not going to like completely replace ophthalmologists anytime soon, but they're slowly like chipping away at it. And so for the medical student, it's probably going to be like, all right, cool. I'm just going to be a general practitioner, and I need to know how to use all these AI tools. And you probably don't need to learn how to code if you don't want to. I mean, it's definitely going to always be useful, because like the startups are just making it easy for the doctors to use this.
Yeah.
And so more and more of that kind of stuff seems to be the trend currently.
Well, and I think, a lot of your company's work too is working directly with doctors and making sure that user interface is useful, because also it's not going to be a very good technology, even if it's a perfect technology, if everyone uses it wrong, it's not going to sell very well.
Right, and yeah, so these deep learning algorithms are very susceptible to their inputs being wrong. So like, if you're inputting text and you've never trained your model to see text with square brackets. And then once you have a trained model and you start putting text with square brackets in, like the model will break if it doesn't see them. And so making sure your inputs are always correct is kind of a huge thing. And, it's helpful if the doctors understand what input is better, but most of them aren't going to. And so we still need to output like a correct answer, because they don't have this error correcting thing like humans have, right? Like, you can look at something and be like, I've never seen that. I don't know, but it looks weird based on all this other stuff that I've learned in my life, right?
Yeah.
The deep learning algorithms don't have that yet. And that's always kind of a worrisome part. You can also get these things called adversarial examples. Not only can you just break the algorithm, you can actually cause it to give you the wrong answer. And so one of the, probably the most famous example of this, I think, is the stop sign classifier. So people train this classifier to recognize a stop sign and be like, okay, if I'm in a driverless car, I should recognize this is a stop sign, I should stop. But just by injecting certain pixels or putting black tape in certain patterns on the stop sign, you can actually get it to not say it's a stop sign anymore.
Oh gosh.
It's still obviously a stop sign, right? It's still an octagon
right.
and whatever. It's a stop on it. But and still seeing all that, you can get it to break the algorithm just because it hasn't seen that in its training data.
Yeah. That's so interesting, those little logic checks that we learn innately of, and even things I think about those experiments where as they watch babies' brains develop in the different developmental stages, where they have the experiments where they put babies on glass over a screen or something that looks like there's a huge drop, and that there's differences when babies age if they're going to walk over the glass, if they crawl over it, if they understand that this is something dangerous.
Oh, wow.
And yeah, it's really interesting. It's at some point they realize this is dangerous, I don't like it, and then as they get older, right, there's this kind of learning curve of realizing, oh, this is height, this is bad, to getting older and saying, oh, this is glass, I'm okay.
Right.
And those kind of cues of integrating, okay, this is a huge height, I need to be afraid, but also this is a floor and I see other people walking on it.
Right.
And that's so complex for a computer.
Yeah, and so not only are you learning that this glass is there and I'm not going to fall or whatever, but you're also learning that glass has this property of I can see through it, but it's a solid that I can't pass through. And you can apply that to every time you see glass. So every time it's weird, kind of mostly clear thing, but kind of smudgy, you can learn that oh, I can go press on that and I won't fall out, or I'm in a skyscraper, or I'm underwater, or I'm in a car, or there's water in my cup, right? You apply that to all different things just automatically. And that's something a computer, once it learns this thing, it's difficult for it to apply to other things. Yeah.
Speaking of brand new things, kind of. So we've got the chemistry of a PhD asking, is AI or machine learning being used to check out COVID? And says, besides the Postera Moonshot project. I don't know what that is. But yeah, are we using computer tech to figure out COVID stuff, or how do computers and COVID, do they have anything to do with each other?
Oh God, yeah. So there's a lot of applications of computers in medicine that aren't machine learning or deep learning or AI or whatever. Right. So one of the earliest things that got done was people got a crystal structure of the S protein and ACE receptor, the human ACE receptor. And so they just ran every FDA approved small molecule through it to see how well it would inhibit docking. And so that set up a bunch of molecules to test then in vitro and in vivo. I don't know if any of those actually panned out or whatever, but that was those initial screens happen all the time. And what's interesting is a lot of those. So what is it? Rosetta and other protein modeling has typically been done using Newtonian physics, and David Baker's lab at UW, I think used to be the best one for you get a new protein amino acid strand and then trying to predict the structure of it. And like DeepMind came into that competition, the CASP competition. I don't know what that stands for, but you basically, so like you X-ray crystallography a bunch of amino acid strands, and you get the structures, and then you don't tell these groups what the structure is, and they use their computational modeling to do this, to try to predict the structures. And then you have a competition at the end of the year, every other year or whatever, to see whose models predict the structure the best. And for years and years, it was this thing called Rosetta or similar. But DeepMind did it with a deep learning algorithm at the last competition and just wiped the floor with them. Like, it wasn't even close. And like DeepMind doesn't have any expertise in computational modeling of proteins. Like it was just all deep learning. Like they had some data, they had I think it was like a convolutional neural net. They actually have the papers out. You can see what it looks like. And
yeah, I'll get right on that.
It's really interesting, but it's like just with data, you can take data and you can turn it into insights. And so like this happens with chemistry all the time. So you can predict the smells of small molecules with deep learning if you have the training data to do that. With COVID, I don't know some of the specifics. I know people are like, we have a summarization algorithm at RadAI that we tried to apply to summarizing COVID papers. It kind of worked. We need more training data to make it better. So we had on the order of like a couple 100,000 training samples, but like we need like probably tens of millions to get it right. So it's not like, in that regard, it's not really feasible. I'm sure there's people who are doing antibody design with deep learning for COVID. Yeah, I don't know all the I don't know specific projects though.
There's so many projects, and then I definitely want to make sure to get to this one because also, okay, so the random question that came up that relates is Mark says that begs a new question about earlier, whether we'll have cyber eyes before we have full AI ophthalmologists. But the question that Adam Quinn 12 asked is really the question we all ask of like cyborg bodies, yay or nay, or should I get part? Should I get like an eye? I don't want an eye. I like really like to have my eyes in my head, but like I would like to have a very strong hand. I don't think I'd want to give up my hand though. Should we integrate humans and computers?
Well, so it's already happening. Like I love talking about, like, you told me not to mention Elon Musk, but like he has this, one of his companies is called Neuralink, and they're building high resolution electrode arrays. And so like electrode arrays already exist in the human body. Like so there's deep brain stimulators for people with Tourette's or seizures or Parkinson's. And then like the cyborg eye that someone just mentioned, there's this disease called retinitis pigmentosa where you lose the pigmented cells in your retina, which these are the cells that like turn light into uses rhodopsin to turn photons into action potentials, and those go away. I believe it's an autoimmune attack, but like your optic nerve and stuff, all that infrastructure still exists to transduce the photons into action potentials to the brain, to the vision center. And so people will just put a 10 by 10 electrode array, so 100 total electrodes. You implant, an ophthalmologist implants it into the retina of the eye, and you wear a camera on some glasses, and it turns that image into a 10 by 10 pixel array. And so now these people who become blind later in life are able to see at 10 by 10 resolution. So it's terrible. It's only in grayscale, but you go from being blind to being able to see the outline of a door or the step, or like you can see traffic or whatever. And so like it's not great, but it continues to get better. And so like the problem is that these electrodes are not like, they're pretty big. They kind of like introduce an inflammatory response. And so that's what Neuralink is working on. There's other companies like Kernel and I can't think of any others on the top of my head. They're trying to make these really small electrode arrays so that you can interact with the brain or other central nervous systems, so that you could, like I have a spinal cord injury, so that you can bypass that injury in the central nervous system. So it's, yeah, we're definitely going to interface with computers in some way like that. Like, right. amputees have been doing it for a long time as well. It's just that's peripheral, so like that's a little bit easier to do. Um,
Yeah, and maybe it's that connection, it's that interface. But then we also have pacemakers, right? Like this is, you know, I don't know. It's something that, in certain ways, I just think it's really cool that humans can extend themselves into these things. And I love that so many people brought up some of the moral implications and some of those big pieces that we really need to be keeping in mind. And like you said, any piece of technology can be used for good or bad causes, and it depends on really the person creating them and using them. So I always ask this last question. I always forget to tell people that I'm going to ask it, which is what related to these. You look terrified. What related to these topics are you looking up? Like, what are you interested in? What are you posting about? Like, what are you excited about in these kinds of topics?
and these kind of that's a wide range.
Yeah, no, just like one thing, and that's your favorite thing ever.
My favorite thing.
I'm just kidding.
Uh, um, yeah, well, so one of the big things that I care about is, you know, you kind of mentioned like the moral implications of AI and medical AI and medical improvements, and like it's like no secret that you know, new medications benefit the wealthy first, and then eventually, like, I hate to use this term, but like trickle down to everyone else. And so one of my big interests is like how can we apply medical AI? Like how can we allow like developing countries, like low and middle income countries, to like leapfrog over like all the like stuff that the United States had to deal with or other Western countries. So like, you know, I went to this cancer conference in Mozambique in November, and you know, Mozambique has like 30 million people and one radiologist. Yeah, and one pathologist, and that's not unheard of in sub-Saharan Africa. And so, like, you know, it takes after college, it takes nine plus years to train a radiologist. So, like, at the minimum, they're a decade away from having radiologists, like enough radiologists. So, like, and they're not going to, right? Because they don't have the residency training programs to do this. So, like, can we build like some sort of radiology AI, you know, in the United States and Europe or whatever, that can help these countries like leapfrog over existing tech? Have they done this before, right? Like everyone in these places has a cell phone, and very few people have a landline because like that technology made it over there, and it was cheap enough that they were able to make use of it, right? Like a single inference event for chest X-ray for our like developing radiology AI, like I don't know, like 5 cents, less than that probably. And so, you know, there's all these kind of issues of biases, like, right, if you have this, you know, chest X-ray classifier that's been trained on a bunch of white folks in the United States, like how's that going to transfer to places in Africa or, you know, places in like Southern Asia or whatever. But yeah, helping them be able to do like train these things for themselves is like I think one of the better ways of like getting this stuff out to the most amount of people. So that's something I'm very excited about, that like pulls a bunch of things together and hopefully will benefit like a bunch of people.
That's pretty cool. I don't think we've ever actually talked about that part, so this is fun. All right, well, Jeff, like, yeah, are you cool with people reaching out to you? If so, I can put your social media handle in the Lincoln thing. I just realized that your name has been covered this entire time. Where'd it go? It's behind.
That's fun.
Aha! But it also still doesn't have your handle because I wasn't sure if you wanted it or not. So your name is Dr. Jeff Snell, and it's so fun, Doctor. Are you cool with people?
Dr. Susanna Harris, actually. I think this might be the first time we've chatted since you have your doctorate, by the way. So
I think it might be. Yeah, and it's also, you're probably throwing some people right now because I know who my like OG friends are because they call me Susie, and so like probably like 20 some of the people who have been watching are like, who is? Does he not know her at all? Did he not even look up her name beforehand?
Who is this? I don't know. Some YouTuber.
Some YouTube, just yeah. Who is this? Do I know you? Awesome. So yeah, are you cool with people reaching out, or I can also forward on questions for you.
Yeah. Just I mean, my Instagram's fine, or you can forward it, questions, whatever.
Yay! I'll just answer them for you. That'll be really helpful.
Yeah. I think people will know if you answer them or not.
Oh, jeez. You're not wrong. All right. Thanks so much, Jeff. I will talk to you super soon, like after this call. But okay, everybody, thank you so much for sticking around. This was really, really fun. I love talking about things that I have no idea what I'm talking about. I think that's the most fun because you just get to learn all of this new stuff. And it is amazing, too, when you dive into these deep topics of bioinformatics and medicine. You have to remember that it overlaps with so many other human issues, and talking about biases, talking about sample sizes and what the moral and ethical implications of these things are. Anyway, I think it's awesome. If any of you have other cool people I should talk to, please let me know. I'm interested in talking about all topics regarding science. This is like my favorite science lesson to myself every week. Hit me up on social media. My handles and things are in the description. And yeah, keep in touch. Let's keep asking questions. Thank you so much for being so nice. Okay, bye. It's amazing. Okay, I'm back. It's amazing